Thank you, Mr. Chairman, ladies, gentlemen. In this talk, I'd like to concentrate on theoretical questions of theory development. Why is it's the overview. I will start with a practical problem, then I will give you some overview of the research context, and we will discuss this new structural integrity concept, and I will give some conclusions at the end. What is the main problem? The problem at hand is the structural integrity of a large-scale pressure systems, like a reactor coolant system of a VVR 440 NPP unit, which comprises of the reactor pressure vessel. Is it not working?
It doesn't. Just check.
Okay.
You have to go down.
No.
This.
I wanted to use the pointer,
laser,
but
laser
doesn't matter. Which comprises of the reactor pressure vessel, steam generators, the pressurizer, emergency core cooling system tanks, and main coolant pumps, and also the pipelines. These systems are designed for a finite lifetime, which is called at first design service lifetime with design safety calculations. The design safety calculations give first value for the prognosis for the lifetime of the unit, which can be or must be, this calculation must be repeated for the operating system, the so-called structural integrity calculations, which give a value for the technically allowable lifetime of the unit, which are, because of the better materials, then they are assumed during design, they give a higher lifetime. Nowadays, we are facing with a new challenge because the owners want to use these units in the so-called long-term operation regime, which is more than 2 times the original lifetime, when some synergetic effect in aging can appear, but nobody knows when. That's why we started a research project about 6-8 years ago to see what are the possibilities to improve the calculation methodology. At first, we made an overview of the design safety calculation methodology, which is based on a discipline worldview. These calculations are a coupled system, a loosely coupled system of thermal field calculations, stress strain calculations, aging, and fracture mechanical calculations. The thermal field calculations are based on the classic theory of heat conduction, the stress strain calculations on strength calculation methodology or theory. The fracture mechanics calculations are based on global fracture mechanics approach, but the description of aging has at the moment no unified or accepted theoretical basis. The main question of the research was how to generalize the methodology so that we can justify that a new approach is good or better than the original one, and that the generalization is plausible. It is not a trivial task. At first, I want to give a general note. We know that the culture or human culture is a unified one, or there is only one culture. But nowadays, a progressive specialization can be observed, which causes many problems even in complex technical projects. But we have to understand that any cultural field, any scientific field, or any other cultural field offer merely partial information about the world. But there are connections between the various fields which may not be immediately apparent. But this means that different branches of culture are not independent of each other, but they form a so-called entangled system. The notion of entanglement was originally introduced in quantum mechanics 90 years ago, and is nowadays has a bigger respect. And this is the entanglement is the essence of a so-called holistic worldview. And it means that the philosophy, the science, the engineering and practice must be seen as an entangled system. Why philosophy is important in this system? Because you think I'm a bit crazy, then I inform you or remind you that the scientific methodology, which is used widely in our sciences, is based on a very old methodology, which comes from Greek philosophy. It's the so-called analytic synthetic method of Aristotle, which is very good for development of a discipline. But in this method, revising the basic principles of a theory is excluded from the methodology. The methodology finishes there. That's why I made a study, a literature study, and it became clear that there is another methodology, also since the Greek times. It was first formulated by Plato. It is called the analytic method, which allows to revise the basic principles of any theory. Revising the principles of the theory is inherent to the method. This is what. So we changed the methodology, and the analytic method can be seen a generalized new scientific methodology, and it is like a conceptual shift in the epistemology. And this conceptual shift on the philosophy level helped us to shift from the old disciplinary approach to shift to a modern holistic concept, which is based on modern thermodynamics. So what are the consequences on scientific level? The main message of the new view is that the new methodology is based on an energetic entropic approach, which unifies the existing approaches in structure integrity calculations or anywhere. And modern continuum thermomechanics belongs to the energetic entropic approach or energetic entropic paradigm, because thermodynamics is a field theory developed to describe the time-dependent dissipative processes in homogeneous systems with finite state change rates. So the novelty of the method is that the dissipation evaluation is governed by the second law of thermodynamics, which acts like a common rail fuel system in modern diesel engines. So the concept follows in our approach the nonlinear field theory of fracture mechanics. I will skip the technical details. And the main novelty of this approach is that the J integral is path dependent in general. It means that the J values around the crack front can be different from the far field values. And this new J integral is inherent. It's a consequence of the new theory, and this paves the way for the integration of local approach models to use in fracture mechanics. So at engineering level, we made an industrially relevant case study for the so-called pressurized thermal shock calculations, which is based on a safety relevant thermohydraulic situation where repressurization during the transient occurs. And we calculated the results for the new state, elastic plastic states of the reactor pressure vessels materials, and for the aged state of the reactor pressure materials. And as you can see in both cases, from a certain point of the transient, the path dependency of the J integral occurs, which is most significant during unloading, which is the so-called warm pre-stress effect. And this calculation are meaningful in the new framework, while this situation cannot be interpreted with the J integral by Rice. So in conclusions, the main message of my talk is that the novel research methodology, the analytic method, can be seen as a generalized scientific method. Thank you for kind attention.